Today we're going to continue 5.6 inverses of functions. So the first thing we'll talk about is a composition of functions. So this is when you plug one function in as the variable in the other function. So we have f of g of x, and if you notice, g of x is inside the parentheses where an x normally would have been. So that means I would be plugging in the equation that is g of x for the variable in f's function. Then we would have g of f of x. In that case, the f function, the f equation, is going to be plugged in or substituted for the variable in the g function. So let's look at what that actually is. We have f of x equals 3x and g of x equals 2x plus 5. So I'm going to find f of g of x. So I'm going to take the function that is f of x. That's 3 times x. But instead of putting the variable, I'm going to put parentheses. So this function is 3x. And now I'm going to substitute in the g's equation, 2x plus 5. So now I'm just going to distribute, and I get 6x plus 15. So f of g of x is 6x plus 15. In part B, I want to find g of f of x. So I would rewrite my g function, 2x plus 5, to x plus 5. So again, I'm putting parentheses in place of where the variable was. And now I'm going to substitute in the value that was f, which is 3x. Not much to distribute this time. I'm just going to do 2 times 3x, and I get 6x. And this stays as plus 5. All right, so they're slightly different, right? F of g of x was 6x plus 15. G of f of x was 6x plus 5. All right, we'll do another one. F of x equals x squared, and g of x equals x plus 7. So for f of x, it was x squared. It's a value squared. So if we were to plug in this for the parentheses, we have x plus 7 squared. Remember, that really means x plus 7 times x plus 7. So we're actually going to have to FOIL or distribute this out. So we get x times x is x squared. X times 7 is 7x. 7 times x is 7x. And 7 times 7 is 49. So that means f of g of x is x squared plus 14x plus 49. Then we can look at g of f of x. So that means we're going to look at the g function as the outside, x plus 7, or parentheses plus 7. And I'm now going to substitute in my f function to the parentheses. And there's nothing to really do here. So g of f of x is x squared plus 7. Okay? Try the next one, find those compositions, pause, and when you're ready, come back and check your answers. All right, so these are very similar. F of g of x is negative 4x plus 2, whereas g of f of x is negative 4x minus 2. The reason we're talking about compositions of functions is because I can verify or tell if two functions are inverses by finding both compositions, f of g of x and g of f of x. If both of them equal whatever variable was being used, in this case x, they are considered to be inverses. So let's verify that these functions are inverses. So f of x is 3x minus 1, g of x is x plus 1 over 3. So I'll start by doing f of g of x. So that means I'm going to take 3 times whatever missing parenthesis, whatever missing variable it is, minus 1. I'm going to plug in my whole g value here, x plus 1 over 3. And when I start to simplify this, 3 over 3 cancels. So now I'm left with x plus 1 minus 1. And plus 1 minus 1 cancel each other out. So I get x. So far, f of g of x does in fact equal my variable x. So now I'm going to do the other one. I'm going to do g of f of x. So g of f of x, I have the variable on top of my fraction. So x plus 1 all over 3. And now I'll substitute in my f, which was 3x minus 1. So that means the top is 3x minus 1 plus 1. So the minus 1 and plus 1 cancel. So we're left with 3x over 3. And now 3 over 3 is really 1, so it's just x. So f of g of x equaled x, g of f of x equaled x. These are inverses. Ooh, this is going to be a good one. These are inverses. All right, if they both didn't equal x, then it's not inverses. So you guys try this last one, pause, when you're ready, come back and check the answer. Verify that they are inverses. All right, I showed you all the work this time. So if we did f of g of x, we get x. If we did g of f of x, we get x. So yes, they are inverses. And that's it for today.